Hello guys, welcome back to Med Zone African Motives. We are still on our revisions, on our introductions. As I said, guys, we shall be working with introductions and at the same time trying to work with question papers so that we see how to answer some typical questions. But this is an introduction that we have on the factorization. Remember, we had factorization of quadratic expressions where you're just dealing with quadratic, whereby just giving a trinomial. It can be a binomial. Depending with any type of an expression, we can talk of difference of two squares, which gave us a minus b into a plus b. There were different expressions that we worked with in this type of in the factorization part. So we're going to see that we still have a factorization, but this time a little bit different from what we had. The first thing that we are going to notice is working with the exponent of 3. It's not like we never worked with this. We worked with some expressions. Maybe it's x to the exponent of 3 plus x squared, or it's x to the exponent of 3 minus x. It's a different scenario that we have. Here we shall have a condition whereby the first term and the last term are perfect cubes. All right, they are perfect cubes in this case. What is a perfect cube? That is the question. What is a perfect cube? Just like a perfect square, a square. A square is a number that you're taking like 2 to the exponent of 2. That's 2 squared, which is 4. 3 squared, which is 9. 4 squared, which is 16. So all these numbers that we are seeing here are perfect squares from the square of a number. So it follows that when we are talking about the perfect cubes, we are referring to numbers such as 1 to the exponent of 3, which is a 1, 2 to the exponent of 3, which gives us 8, 3 to the exponent of 3, which gives us a 27, 4 to the exponent of 3, and so on and so on. So these are the numbers that you're going to refer. 4 to the exponent of 3 is something like 64. Yeah, that's something like 64 there. So guys, meaning to say that on a condition that I am to simplify this, I must be knowing the cubes, the perfect cubes raised to the exponent of 3. These are your perfect cubes. So now what is this type of factorization? This is the sum and the difference of two cubes. In this case, we are referring to a condition that if we are dealing with the sum or difference of two cubes, consider that we have got x to the exponent of 3 plus y to the exponent of 3 like that. These are perfect cubes. They are raised to the exponent of 3. So we are going to have a condition where we have x plus y. So you need to note this. It's like just like trigonometry. We've got ratios, trigonometrical ratios, or identities. So it's something that you are supposed to know or to note how to apply it. All right. So you're going to have x plus y, which is the sum of the first and the last term. Then we're going to have x squared minus the product. So you're going to have the product of x and y plus the square of y in that case. So what does it mean, this part? It means we are going to have this x raised to the exponent of 3 is your first term. That is your first value or your first term, just like what you're given here. Then this represents your last term that is raised to the exponent of 3. So you're going to add the first bracket, the first and the last term. Then the second bracket is going to be the first to the exponent of 2, the product of the two, which is minus the product of first, last, plus the product, plus the last squared, which is the last to the exponent of 2. So this is the scenario that you are going to have. So all you just need is to memorize your identities, just like I said, it's just like an identity that we have in what? In algebra. So we have x to the exponent of 3 minus y cubed, which is this time, since we have a negative here, we are going to start with a negative x minus y. Then here it adds. So it's going to be x squared plus the product of the first and last plus the last squared. So that is what you're going to have at the end. So It's like I'm explaining, as long you know the presentation of your identity. It's like when you know that tan of theta is equal to sine of theta over cos of theta, you can use it where you have something of this nature to simplify. So it is the same thing like what we have. You can be able to factorize whatever that you have as long it can be raised to the exponent of 3, being added or being subtracted. That is why we are talking about the sum or the difference. Remember, on the difference of 2 squares, we only have a difference of 2 squares. We do not have sum of 2 squares. But on the cubes, we can have the sum. It's there. So do not confuse between the difference of 2 squares. All right, so let us see the first question. We are asked to factorize the following. Question number 1, 27 x to the exponent of 3 minus 1. All right, so let us check what we have there. We are given 27 x to the exponent of 3 minus 1. All right, so that's 27 x to the exponent of 3 minus 1 in that case. All right, this is what we are given. So what you need to ask yourself, guys, is that do I have this condition? Yes, I'm subtracting, but are they cubes? Is 27 a cube? So I have to test. I can even test on my calculator, meaning to say I just find, because it must take note, guys, what I'm saying here. This is to the exponent of 3. So to test that a number can be raised to the exponent of 3 like this, you test by finding the cube root of that number. So you find the cube root of 27. That number, if you can obtain a whole number, it means this is a cube. If you obtain what? An integer, which can be positive or negative, or number for the cube, you can have positive or negative. So we are going to determine the cube. So for the cube, you can use this already. It's a cube there. So it's a shift. You go to the cube like that. So it's the cube root of 27 like that, which is a 3. Or you can use this one on here, this one or this part, the cube like this, but you have to write 3, then write 27 like that. So as we can see that the cube root of 27 is a 3, which is a whole number in that case. So that means this is a cube. So meaning to say, if I write 3 to the exponent of 3, it gives us 27, because the cube root of 27 is 3. So that means 3 to the exponent of 27, to the exponent of 3 is 27. Let us test on our calculator. 3 to the exponent of 3 is equal to 27. The same thing, you go to this one, you do the same thing, you find the cube root of a 1 in this case, which is going to give you a 1. So it means if the cube root of 1 is equal to 1, that 1 to the exponent of 3 must give us a 1. Just like what we saw, that the cube root of 27, all right, the cube root of 27, we saw that it's a 3. The cube root of 27 is a 3. So it means 3 to the exponent of this number 3 must give us 27. It must be equal to 27, just like what we saw. So meaning to say these are cubes. Already this one is raised to the exponent of what? Of 3. So we are going to write this term as 27, which is 3 to the exponent of 3 times x to the exponent of 3 minus 1. We said it's the same as 1 to the exponent of 3. It's the same thing for 1. It does not change. All right. But remember, guys, from our indication of our exponents, we can actually combine this from our grade 9 concept, guys. We say this can be written as 3x everything to the exponent of 3. We have got the same exponent, so we can have it in a bracket like that. So it means I have got 3x like this, everything to the exponent of 3 minus 1 to the exponent of 3, so that I can properly see my first term and my last term. So this is same as we've got x like this one, x cubed minus y cubed like that, whereby this is your first, this is your last term. So as we can see from that condition, our answer is supposed to be given as x minus y, which is the first term. Like I said, the first, and this is our last term. So it's simply first minus the last term, which is the first term minus the last term. So it's going to be 3x minus the last term, which is 1. All right, we have to square x squared plus xy plus y squared means we're going to have the first term to the exponent of 2, which is our first term is 3x. So it's going to be 3x, which is our first term to the exponent of 2. But remember what we had here, 3 to the exponent of 3, x to the exponent of 3 is the same as this part. So if I'm given this, I can rewrite the same way that I had before. So this means I've got 3 to the exponent of 2. So I'm going to have 3 raised to the exponent of 2 and also x raised to the exponent of 2. So that's 3 to the exponent of 2, which is 9x squared. So that means here we are going to have 9x squared for the part representing the first squared, the first term squared. So it is going to give us 9x squared. Then as we can see, we've got plus xy, which is plus first times last. So we multiply the first and the last, but we add in this case. Then we multiply the first term to the last term, whereby our first term is 3x. The last term, which is this one, is a 1. So 3x times 1, remember, it gives us a 1. Any number multiplied by 1, it remains as it is. So meaning to say we are going to have 3x. Then the last part is the last squared, which is the last term to the exponent of 2. And the last term, in this case, it's 1. So that's plus 1 to the exponent of 2, which is 1 times 1, which is 1. So this is going to be a plus 1. So that's, we have factorized this expression that we are given, the cubic expression, fully. As long you can write this as a number, first term raised to the exponent of 3, which can be a plus here, or it can be a minus, as it is a certain number to the exponent of 3 again. You can use your factorization direct, just like we saw here, application of our laws that we have in this case. All right, so let us check, guys. We're not going to answer like all of the questions, but just going to try to have a basic understanding so that you can be able to answer as much questions as you can on your own. Let us consider this one that yes, got a positive, but as you can see, there's a 1, which is the same as the last part that we had. So this is 8x cubed plus 1. So you're going to have 8x cubed plus 1 in this case. All right, so that is our second question. 8x to the exponent of 3 plus 1. So is it that these are perfect cubes? These are they cubes? So like I said, to test, you're just going to find the cube root of 8 because it must be raised to the exponent of 3. So the reverse of to the exponent of 3, which is the inverse, is the cube root of 8. And from our calculator, we are going to test. If you know the cube root of 8 by head, it's fine. You can write, which is 2, but you can use your calculator. The cube root, you're going to write a 3. If you use this part, all right, that is the cube root of 8, which is 2 in that case, all right? So that's going to be a 2, meaning to say 2 to the exponent of 3, it gives us 8. And we have got x to the exponent of 3 plus 1. We talked about it, guys. We said 1 is the same as 1 to the exponent of 3. So like I said, if it is a condition that you're multiplying and the numbers are raised to the same exponent, you can write it as a single term, that is 2x, everything raised to the exponent of 3, plus this is 1, which is our last term to the exponent of 3. I'm just going to open a bracket so that you can properly see to say we are working with this being our first term and this being our last term. So as we saw from our formula that if it is an addition like this, we are going to have the first term plus the last term, right? Like we have here first term and last term. So it's going to be the first term, which is 2x, plus the last term, which is 1. But on this bracket, we're going to have the first squared, which is the first term squared. That is 2x raised to the exponent of 2. That is the first squared. This is your first term. So you're going to square that first term to the exponent of 2. That's 2 to the exponent of 2, which is going to give us a 4. 2 times 2, that's a 4. x to the exponent of 2. So that means you are going to obtain this bracket 4x squared minus first and last. So you're going to minus the product of the first and the last. So that is minus the product of the first, which is 2x in that case. All right. So our first times last, which is 2x, times the last term, which is 1. So 2x times 1, that is a 2x. Remember what I said, if you multiply by 1, this term is just going to remain as it is. Then the last squared, which is the last term, to the exponent of 2, which is our last term, it's 1. 1 to the exponent of 2 is 1 times 1, which is what? Which is 1. So that is going to be a 1, or you can just use your calculator to raise, sorry for that, to raise 1 to the exponent of 2, which is going to give you what? A 1. So this is what you're going to have in final terms, and this is in factorized form, and you cannot factorize further than that. It gives us a factorized expression that cannot be factorized further than that. That is how you can answer these questions. All right, so let us check other questions that you're given. Like I said, I'm just going to leave this part so that we can we do not keep on repeating, rewriting these. I'm just going to leave them like that. So let's just check maybe 1 or 2 of the questions. Some of the questions, they might not be direct here. We just use the numbers, they are direct here. We're going to just use them as they are. I explained this part, same as this one. If there's a number, all right, but there are some numbers which are not direct, like this one that we have on question number 6. These two numbers, if you check, it's 5x to the exponent of 3 plus 40 in that case. All right, so this is number 6, 5x to the exponent of 3. So if you have a challenge on the questions that I skipped, let me know, guys, on the comment section so that I can work them or we can work them together on another class. All right, but I want you to try these numbers so that you see if you are together. But if you have a challenge on these numbers that I've left out, let me know so that we can work them together. All right, question number 6, we're given 5x to the exponent of 3 plus 40. All right, that's question number 6, 5x to the exponent of 3, all right? 5x to the exponent of 3 plus a 40 in this case like this. So if you had to check, you'll be wondering, if you're someone who knows like the perfect, like if you know your cube, the cube values that this one, it's a cube, this one, it's a square, this one, it's not. If you know those terms, if you actually someone who knows that, you can properly see that, this here is not a cube. We cannot have a number that we can find its cube. It's when it's even 40 here, we cannot have the cube root of this. But this is not something to worry because you have the calculator. All right, so you can just go back to your calculator. Like I said, everything the calculator answers for us. So we are going to have the cube root of this. Remember, I said you have to determine the cube root of these numbers to check if it is what? A perfect cube. So you're going to have the cube root. All right, so sorry for that. The cube root here. Why am I not pressing the shift? So that's shift here. All right, so that's the cube root of a 5 in this case like this. And this gives us a decimal, which is not a whole number. So that this is not a cube. You do the same thing on the cube root of 40. That's the cube root of 40 in that case. As you can see also, it is not a perfect cube. So what does it mean? Does it mean this question is wrong? No, it doesn't mean this question is wrong. Remember our factorization, the golden rule. Whenever there is a common term, you have to factor out that common term. What is the common term? That is the question. We have got 5, we have got 40. What is the highest common factor? We have the common factor, the highest common factor between these two numbers. So if you check properly, 5 is the highest common factor there between 5 and 40. Remember, we have 5 in 40, so we can factor out that 5 that is being the highest common factor first. And we factor out that we have to divide. So that's 5x to the exponent of 3 divided to 5. 5x to the exponent of 3 divided to 5. This will cancel. You remain with x to the exponent of 3 in that case, right? You do the same thing on this 40 that we have. If we divide this by the number that is outside, which is 5, you are going to obtain 8. So that is going to be plus 8 in that case, which you have to check again. Am I having back the cube, the perfect cube? Already here I'm having a cube, but what about 8? Remember we worked with 8 before. We saw that this one, it's a perfect cube. But even though you have forgotten, go back to your calculator, all right? As usual, gonna find the cube root and check again, because it can be a possibility of having a sum of what? Of 2 cubes from there, all right? So that's gonna be the cube root of 8 in this case, which is going to give us a 2. So that means this number here is a perfect cube because its cube root is equal to 2. So that means 2 to the exponent of 3, it gives us 8. So if it is the scenario of, if it is the situation, therefore let us substitute so that we write in this format that we are given here. So how are we going to write in that format? It is going to be 5 into x to the exponent of 3 plus we must have a number to the exponent of 3 or a term to the exponent of 3, another one to the exponent of 3. So 8 is same as 2 to the exponent of 3. So that's going to be 2 to the exponent of 3 like that. So we have our condition just like the previous case where we have got our first term and this being our last term. And we are adding in this scenario. So if we are adding, we are going to use this condition here for adding, where we said we are going to have, all right, so the 5 is simply there to multiply our answer. So we said we're going to have the first plus the last term, which is the first term, that is x, plus the last term, which is 2, all right, into the bracket of x squared, which is the first term. So our first term is going to be x squared minus this time, all right? You are having a plus, there you're going to subtract product of first and last. So it's going to be the product of first and last, which is our first term, there it's x. Our last term, it's 2. So x times 2, it gives us 2x. So that is going to be a negative 2x in this case. Then we move on to the last part, which is the last squared, which is the last term squared. And our last term here is a 2. So that's 2 to the exponent of 2, which gives us a 4. So that is plus 4, which is the last term squared, the last squared, the last squared, which is the last term squared. So that is how the questions are given, guys. As we can see at that stage, we have had factorized all like everything in simplest form. You have factorized everything in simplest form. All you just need is to understand how your questions are given. So I just want us to have something that has got a fraction. Then guys, like I said, you're gonna try to answer these questions as much as you can. Then if there are questions that you still have a challenge on these questions, let me know, guys, so that we can revise those questions together. So I want us to check the question number 11, where we have a fraction in that case. That's x to the exponent of 3 plus 1 over x to the exponent of 3. All right, so it is the same situation that we have from the previous questions that we had, guys. We are having same situation. So this is question number 11. All right, so remember what I said. If you are given a condition where you are adding, and these are perfect cubes, and you are having a condition of x cubed plus y cubed, which represents the first term, plus the last term being raised to the exponent of 3. We're going to have this as the first plus last, because you're adding, then you're going to have x squared minus the product of first and last, which is xy, plus the last squared, which is y to the exponent of 2. So can we write these expressions in that format? That's all. That's all. Once we can do that, we are done. So we have x to the exponent of 3, okay? That's x to the exponent of 3 plus 1 over x to the exponent of 3 is the same as I'm writing as 1 over x with everything being raised to the exponent of 3. Remember, 1 to the exponent of 3 is 1. X to the exponent of 3 is x to the exponent of 3. What I simply want is to properly see my first term and my last term. If I can properly see these, I can factorize this because I'm going to have the first plus the last, which is the first, which is x. Remember, this is your first, this is your last. So it's going to be first plus last, which is first plus our last, which is 1 over x. So we are going to add our terms as they are, which is plus 1 over x like this. All right. Then we move on to the other part, which is into x squared, which is the first term squared. So that is our first being squared. So it's going to be x squared minus, in this case, we're going to have the product of first and last. So we have first, which is x, times last, which is 1 over x. So as you can see, this is same as over 1. So we're back to multiplication of fractions where these two can cancel. We get a 1. 1 times 1, which is a 1. So this is going to give us a 1. All right. Then the last part is y squared, which is the last squared. So it's going to be 1 over x squared like that. But remember what we talked about, guys, whenever you are simplifying a squared like this, just like what we had on 1 over x cubed, we said this can be raised to the exponent of 2, and also this can be raised to the exponent of 2. So if that is the situation, I'm going to have 1 to the exponent of 2. So here it's a plus. So 1 to the exponent of 2, which is 1 times 1, which is x, over x to the exponent of 2, which is going to be x to the exponent of 2 in that case. So this is how our questions can be simplified as long you have to apply your theorems. I mean, this part of our factorization properly. You can be able to answer any question that you are given. Any question, is it that it is having a fraction? Is it that it is having whatever type of expression that you are given? So it is the same question like this one that has got a negative. The only difference is on the signs there. All right, what about 10? Let me see this 10 here together with you guys because it can have a confusion to some of us there. Number 10, we are given, all right, let me just write this one. All right, number 10, we are given that is 8 minus a minus 1 to the exponent of 3. Remember, we worked with a condition of this nature. Remember, we said this would be x cubed minus y cubed is equal to x minus y, which is first minus last, into first squared plus the product of first and last plus the last squared. If we are to consider this part that we are given, what is our first term and what is our last term? That is the question. What is your first term and what is your last term? So in this case, if we are to consider, we've got the part that we have the first, which is 8, and this part of a minus 1 cubed. So these are perfect cubes. Remember, I worked with 8 before, guys. This is not like something new. We said 8 is same as 2 to the exponent of 3. So it means I have got 2 to the exponent of 3 minus a minus 1 to the exponent of 3, whereby I can properly see my first term and my last term. I can properly see these terms. So if I can properly see these terms, what does it mean? I am going to simply substitute what I'm given in these expressions. So the first part, guys, take note what we're supposed to have. I want you to see what we're supposed to have. We're supposed to have this one as, remember, we said we're going to have the first minus the last. The first is 2 minus, take note, the first is 2 minus the last. This is your last, which is a minus 1. So you are supposed to open a bracket and write as a minus 1. You are back to simplification of your algebraic expressions. So this one, let us just simplify. We just want to write the answer here. As you can see, we're having a lot of things. So we are supposed to have the first term, which is 2, minus the last term, like I said, which is a minus 1, like this. All right. So we're going to expand our brackets. This is negative 1, which is 2. Minus 1 times a, it multiplies everything. That's minus a, minus 1 times minus 1, which is a positive 1. So we're going to add 3 plus, 2 plus 1, which is going to give us a 3. Then on a, this is just going to remain as minus a. So we're going to have 3 minus a in that case. All right. So this whole part that we see after being simplified, it is going to give us 3 minus a in that case. All right. Into, we are going to move on to the bracket here. Remember, we are working with a subtraction. So you're going to have the first squared, the first, which is 2. So that is going to be 2 squared, which is our first term squared. And our first squared is going to give us what? Our first squared, which is 2, is going to give us a 4. All right. So that means here we are going to obtain a 4. All right. Then we move on to the other part, which is the product of first and last. So the product of first and last, which is going to be, it's a plus here. So the product of first and last, all right, let us just multiply 2, which is the first, into the last, which is a minus 1, like that. So it's going to be 2 times a, which is 2a, 2 times minus 1, which is minus 2. So that's the product of the first and last, 2 and a minus 1. So it's going to be plus 2a minus 2. Then the last part here is y squared, which is the last squared, which is a minus 1 squared. So there we are going to have a minus 1 squared, like that. But now, as we are considering a minus 1 squared, guys, we are now back to our normal, remember from our special simplification of algebraic expressions, the condition of x minus y squared, where we say this one, it gives us x squared minus the product of 2xy plus y squared, like that. Do not confuse with this one for the difference. This one, the whole part is being raised to the exponent of 2. So if it is this, if it is like that, we are going to have a to the exponent of 2, all right, minus the product of 2 and these two terms. So it's going to be 2 times a times 1. 2 times a times 1, which is minus 2a, plus y squared, which is 1 squared, which is a 1. So this is what you're going to have. Or you could have, all right, let me just write it here. I'm going to explain it in another way. So this is the last squared, which is y squared, this one. So we are done. We're going to collect our like terms. So like I said, in order to obtain the same answer that we see, you can just expand your brackets, guys. A minus 1 squared means we've got two brackets of a minus 1 and a minus 1. So remember, a multiplies everything in the first bracket. So it's going to be a times a, which is a squared, a times minus 1, which is minus a. We are done with a. We move on to minus 1 times a, which is minus a, minus 1 times minus 1, it's a minus, and a minus, that's a plus. So you're going to collect your like terms, minus 1, minus 1. So that's minus 1, which is minus 2a plus 1. So as you can see, this is the same part that we have here, a squared minus 2a plus 1, which is the same as this part, a squared minus 2a plus 1 that we got from our simplification of our algebraic expression, special expressions. But after that, you have factorized, we have expanded, no matter the way that you're going to choose of all those ones that we had before, no matter the way that you're going to choose, you have done. But in this case, you are supposed now to collect the like terms, as we can see that in this bracket, we have got like terms, a lot of like terms that you have to consider. All right, so a squared has got the highest exponent, and we do not have any other term to be added to this a squared. So I can just write it as a squared. All right, then I move on to the a here. So this is 2a minus 2a. So that's 2 minus 2, which is a 0. I move on to the numbers. That's 4 minus 2 plus 1. So I can use a calculator. If I'm not understanding my directed numbers, I can just use a calculator at once. So remember here we are having, all right, let me show the calculator. So that is 4 here, minus 2. So that's 4 minus 2 like this. Then we are going to add this one that we have here like this. So that is going to be a positive 3. All right. So at the end, we are going to have a positive 3 like this. All right. So as you can see, here there's no way we can go. There is no way we can go. Like I said before, there is no sum of two squares. There is only difference of two squares. The sum is only on cubes. If you work with a cube, there are sum of two cubes. But if you work with the part of difference of two squares with the squares, it's only difference of two squares, not sum of two squares. So that is how you play around with this type of factorization. So like I said, guys, I want you to work out some of the questions that I left out on this exercise. Try to do as much questions as you can, but a hint on this question, you can factor out the negative first. If you factor out a negative, you remain with x cubed plus 27. Then you factor out so long you have that as a positive. You know what to do, guys. I talked about this, and all this part where on a condition where we do not have something direct, factor out, but everything here, I think, guys, is direct. Just try those questions. But like I said, if there's a question still having a challenge, let us know, guys. Let me know on the comment section so that I come back and work that question with you guys so that you'll be able to understand as you prepare yourselves for the exams that are ahead of time.